Welcome to the course on Design of Reinforced Concrete Elements. In this session, we shall consider the materials involved in making of plain cement concrete and reinforced cement concrete and the methods involved in the design of RC elements. Introduction. We know that concrete means it is a mixture of cement, sand, fine aggregate, coarse aggregate and water. So plain cement concrete also, it is a hardened mass obtained from a mixture of cement, sand, gravel and water in a definite proportions. PCC, plain cement concrete, has a good compressive strength, very low tensile strength only carried by the concrete. For example, if it is carried a 100 megapascal, 100 Newton per mm squared is carried as a compressive stress means 1/10 of the compressive strength only carried as a tensile stress. Plain cement concrete used where the good compressive strength and weight are the main requirement. In these situations only plain cement concrete is preferred. The next one is a reinforced cement concrete. Plain cement concrete, we know that very low tensile strength. In order to improve the tensile strength, some sort of reinforcement is added in the concrete, which is taken up the tensile stresses developed in the structures. Then RCC is a versatile construction materials which is strong in compression as well as tension. Use of reinforcement in concrete not only increasing strength but also helps in preventing the temperature stresses and shrinkage stresses. Grade of concrete. The concrete is graded or designated on the basis of its compressive strength. These details are available in our IS 456 2000 page number. Grade of concrete. The table 2 is available in our IS 456 2000. Group of concrete, then grade designation, specified characteristic compressive strength of 150 mm cubes at 28 days in Newton per. Concrete classified as ordinary concrete, standard concrete and high strength concrete. For ordinary concrete from M10 to M20, standard concrete from M25 to M55, high strength concrete from M60 to M80. The 10 means indicated as a characteristic compressive strength of the concrete. Notes, in these notes, in the designation of concrete mix, the mix M refers to the mix and number followed by the M followed by number 10, 15, 20, 25, 30 means it is indicated as a compressive strength of 150 mm size cubes at 28 days. It is expressed in the Newton per mm square or megapascal. So this data is available in our codal provisions. The concrete grades are expressed by a letter M followed by a number. Everything is, these data are available in our code. The letter M refers to the mix and the number represents the characteristic compressive strength of the concrete in Newton per mm square. For RCC works, not lower than M20 grade. At least minimum M20 grade should be used for the RCC work. And for post-tensioning works, M35 and above. For pre-tensioning pre-stressed concrete, M40 and above. So these should be followed for making of post-tensioning. It should be a M35 and above. The concrete should be above M35 and above. For pre-tension pre-stressed concrete, M40 and above. Then grade of cement. The cements are classified into Ordinary Portland cement classified into three categories: 33 grade, 43 grade, and 53 grade. Ordinary Portland cement is commonly used in construction. The Bureau of Indian Standards has classified OPC in three grades, that is the 33, 43 and the 53. This classification is based on the compressive strength of the cement, sand, mortar cubes. So the cube is made up of one part of cement and three parts of standard sand. That means Ennur sand only used as a sand. So one part of cement and three part of the standard sand by weight. And 33, the grade number indicate the minimum compressive strength of cement, sand, mortar cubes in Newton per mm squared at 28 days. So the 33 means 33 Newton per mm squared. It should be reached at the 28 days after curing of cement, sand, mortar cubes. It should reach the 33 megapascal, 43 megapascal and 53 megapascal. Grades of steel. The steel grade of steel classified as a mild steel Fe 250, high yield strength deformed bars Fe 4 and 5, and TMT thermomechanical treated bars or corrosion resisting bars Fe 500. We know that Fe means it is indicating for the ferrous content, and 250 is your minimum yield strength of the steel. 250 Newton per mm squared is minimum yield strength of the steel. So 415 is a minimum yield strength of the steel in Newton per mm squared. Similarly, Fe 500 means minimum yield strength of the bars 500 Newton per mm. Next, types of loads on RCC structures. The structures are designed to withstand the various types of load. Dead loads, IS 875 Part 1, live load or imposed load, IS 875 Part 2, wind loads, IS 875 Part 3, snow loads, IS 875 Part 5, and earthquake load, IS 1893 Part 1. So the dead loads is for mainly dead loads are due to self weight of the structures. These are the permanent loads which are always present. Dead loads depending upon the unit weight of the material. Dead loads include the weight of wall, beam, column, and permanent fixtures also considered in the dead load. Next one, live loads or imposed loads means live load on floors and roofs consist of all the loads which are temporarily placed on the structures. For example, loads of people, furnitures, and machines. These loads are keeping on changing from time to. The next one is wind load. Wind load means the force exerted by the horizontal component of wind is to be considered in the design of buildings. It is depending upon the velocity of wind, shape, and size of the building. Next one is here snow load. The snow load is considered when the buildings which are located in the regions where snowfall is very common. So in these situations, the structures is to be designed for the snow loads. The next one is a earthquake loads. Earthquake loads depending upon the place where the building is located. The India divided into 4 seismic zones. The code gives recommendation for the earthquake resistant design of. The next topic is methods of RCC design. Design of any RCC member comprises of the following. The first one is decide the size of the member and amount of reinforcement is required. The second one is we have to adopt the section, size of the section, and we will check the safety and satisfactory during the lifetime of structures. So first one is decide the dimension of the member. and amount of reinforcement required. The second one, to check whether the adopted section will perform the safely and satisfactorily during the lifetime of structures. So various methods used for the design of RCC structures are as follows. Working stress method, load factor or ultimate load method. The next one is here limit state method. These are the methods of design of concrete. The first one is a working stress method. It is based on the elastic theory. Assume that both steel and concrete are elastic and it obeys the Cook's law. It means that the stress is directly proportional to the strain up to the collapse. This is not true. Main drawbacks of the working stress method of design are as follows. It assumes that concrete is elastic. Concrete never be elastic, so which is not true. It uses the factors of safety for stresses only, which does not give the true margin of safety because we don't know the failure load. And it does not use any factor of safety with respect to the loads. It means there is no provision for uncertainties associated with the load. And also it does not account for the string gauge and creep, which are the time dependent. This method gives the uneconomical section. The next one is here load factor method or ultimate load method. We know the meaning is present in itself in the name. Ultimate load method or load factor method. In this method, ultimate load or collapse load is used as a design load. Ultimate load is obtained by the multiplying working load with a load factor. This uses the real stress strain curve and takes into account the plastic behavior of the materials. So the previous working stress concept, the stress and strain proportional, we are assumed like that. Here the real stress strain curve and also takes into account the plastic behavior of the materials also we have considered. So this gives the very thin section which result in the excessive deformation and cracking, thus making structure almost unserviceable. The next one is a limit state method. This is the most rational method which takes into account of ultimate strength of the materials, positive effect of working stress and ultimate load method. Then finally we will arrive a limit state method. So, so in this method, we have to consider the ultimate strength of the materials and serviceability requirement. So the acceptable limit of safety and the serviceability requirement before the failure occurs is called the limit state. This method is based on the concept of safety at ultimate loads, serviceability at working loads. So two important limit states to be considered in the design: limit state of collapse and the limit state of serviceability. The next one is your multiple choice questions. From above the content, these questions may be asked as a multiple choice question. So the first question is, the reinforcement in RCC takes tensile stress, compressive stress, shear stress and torsional stress. The answer is tensile stress. That is the main reason that the reinforcement are inserted into the concrete, which is only taken up the tensile stresses. So the tensile stress is a correct answer. The second one is the coefficient of thermal expansion of concrete is nearly equal to wood, aluminium, steel and copper. So here the coefficient of thermal expansion of concrete is nearly equal to steel. The third question is minimum compressive strength of the 43 grade OPC cement means 43 megapascal. So 43 Newton per mm square. This is 43 answer. Option B is a correct answer. The next one is IS 456 recommends working stress method of design or ultimate method of design or limit state method of design or none of the above. Actually, the working stress concept, the materials or behaves like a elastic. In the ultimate load method only we have to consider the ultimate load carrying capacity of the materials only we have considered. The limit state method is here the right answer. The fifth one is the yield stress divided by the factor of safety is called as your yield stress divided by the factor of permissible stress. Yield stress divided by factor of safety, that is called as your permissible stress. Thank you.